Golden Power Portfolio by Milos, Everett, and Elijah. Currently, Golden's energy mix is over 60% based on fossil fuels like gas and coal. And of the gas, 30%, 7% is used for electrical energy generation, while the rest is used for heating. And then our plan is to mainly use passive solar efficiency gains of 23%, which will reduce the total energy demand by 23%. And on top of that, we are going to reach over 50% renewable by increasing the solar capacity by 5%. And then if we look at the energy consumption in business and residential, we see that we can make the biggest impact in the business sector in the natural gas for heating, because they have way less customers than residential. So we can be more effective at focusing businesses.
Analyzing our motivation for this process, we want to reach 50% renewable energy by 2025. And this is in line with Excel's goal of reaching 100% renewability by 2050. And in doing so, we're taking a stepping stone towards that goal. And also, we are eliminating greenhouse gases. But looking at our levelized cost of energy, you can see that solar is relatively low, only having natural gas lower than it in price per kilowatt hour. Mind you, these levelized costs of energy are to produce the energy, while that 12 cents per kilowatt hour is what Golden residents are actually paying. And so that solar price is going to decrease year over year. So if we look at that same price in 2025, when the infrastructure is actually going to be put into place, it's going to be even lower.
Okay, so technology explanation for passive solar is basically the use of the sun's direct sunlight for direct heat energy. Mostly for space heating. We have building practices that create houses with a lot of south-facing windows that allow a lot of sun to get in through the winter, heat up the space. And some designs, like the one in the picture on the left, show how overhangs can be used to limit sunshine during the summer and increase sunshine coming in during the winter based on the sun's location on the horizon. And trome walls are used to absorb heat and store it, so that during the nighttime when there's no sun shining in, that heat is released into your space to heat it up. Phase change materials can also be used, as you can see in the graph at the right, where the latent energy is used to heat up the space during changes in heat. Passive solar for heating can also be used by using a heat exchanger on the roof that absorbs the sunlight and warms up a fluid that then warms up a water storage tank, which can be used for radiant floor heating and domestic water heating. On top of this, we are going to be implementing a strategy of installing HRVs into all residential and commercial buildings, which can reduce heating load by 9 to 12%. And this allows us to use passive solar heating for whole house heat. HRVs work by transferring heat from your exhaust air from your bathrooms and kitchens and transferring that to your incoming fresh air that the ventilation system is pumping in. So there's very limited heat loss through air escaping your building. The overview of what we're going to implement is install heat recovery ventilators to reduce heating system loads by 9 to 12%, and install solar radiant heating which is also subsidized through Excel Energy. And we're going to do insulated window shades to block heat loss during the night. This will in turn eliminate natural gas usage for heating and hot water. Our strategy is cheaper than geothermal heat pumps, making it a viable thing for Excel Energy to subsidize instead of their heat pumps.
To bolster production, we looked at solar resources in Golden and determined that Mines owns 240 total acres of vacant land west of Golden, but since Golden has such a good energy resource at 242 sunny days per year, which is above the national average, we only need to use the eastern 80 acres of that plot, which lets us build a farm at about 2 megawatts, which allows us to, along with a battery energy storage system, we can reach 5% of the peak demand. Golden's amazing solar resource also allows us to use passive solar, such as was explained earlier, with trome walls and passive heating directly. Those trome walls can actually save up to 25% on energy for heating buildings, and they're incredibly cheap to implement. Installation averaging at about $1,000 per household. That cost would go directly to households. For the battery energy storage system, again, that would cover 5% of peak demand. And here you can see passive solar was by far the best technology here. It is incredibly cheap, very effective. We looked at hydro also, but it turns out that given a study that was done specifically for Golden, it was entirely economically not viable.
Analyzing the economic analysis of this process results in a total initial capital investment of $42 million. This initial capital investment is incredibly high and will only increase by multiple fold due to high current interest rates. Yet, by looking at some of the political analysis, specifically the Inflation Reduction Act, we can see that there is going to be a large amount of bonus depreciation available. So we can do a lot of write offs in the first year, and we will be looking at a much closer investment to $60 million over the course of a 20-year investment. Also, analyzing that location, it is very likely that mines would be willing to sell that land to the city of Golden, as they would disproportionately benefit from the use of that land, as they are one of the largest energy users within Golden. Also, looking at individuals have higher bills, we are planning on using free HRVs and actually subsidizing that cost. So, over the course of the next 20 years, the investment will be paid off by your lower cost of energy, yet individuals will actually be paying the current market rate for energy rather than having a lower cost. And then once that 20 years is up, they will pay a decreased price.
So in conclusion, passive solar is an essential part to achieving net zero emissions by 2050, and utilizing existing efficiency programs from Excel Energy, we can subsidize our cheaper and more effective passive solar and HRV adoption programs. Similarly, a small investment is required for a large change in resource usage and complete reduction by 23% of total energy usage, which in turn creates a 60% reduction in CO2 emissions with addition of our 5% peak power solar farm. And we are eliminating 63% of natural gas consumption, mainly used in direct heat applications for heating, which will help Exxon Energy reach their electrification goal. It is difficult to guarantee adoption everywhere due to private properties being at stake. And this doesn't take into account expected increases in demand from increasing electrical vehicle usage in the future. These are our citations.